Hello, I'm Robert Benavides. Let's talk about Chapter 11, Part 2, Testing a Class. Now, this will be the end of this chapter. We'll also be covering the summary as well. So as far as testing a class is concerned, let's go ahead and compare that with what we did in the previous section. The previous section of this chapter, Chapter 11, we went ahead and talked about testing functions. So in the first part of this chapter, you wrote tests for a single function. So in this section that I'm going to cover right now, we're going to go ahead and write tests for a class. You'll use classes in many of your own programs, so it's helpful to be able to prove that your classes work correctly. If you have passing tests for a class that you're working on, you can be confident that improvements you make to the class won't accidentally break the current behavior. So what we're going to be using is we're going to be using a variety of assert methods to help us do this. So what class are the assert methods provided from? So Python provides a number of assert methods in the unitest.testCase class. And how do these assert methods work? As mentioned earlier, assert methods test whether a condition you believe is true at a specific point in your code is indeed true. So if the condition is true as expected, your assumption about how that part of the program behaves is confirmed. You can be confident that no errors exist. If the condition you assume is true is actually not true, Python raises an exception. What are some of the commonly used assert methods? Well, we'll see that in table 11.1 that 6 assert methods are described here. With these methods, you can verify that return values equal or don't equal expected values, that values are true or false, and that values are in or not in a given list. You can use these methods only in a class that inherits from unitest.testCase. So let's look at how we can use one of these methods in the context of testing an actual class. So to test a particular class, let me go ahead and open up Visual Studio, Visual Studio Code. And I'm going to go ahead and close whatever I have here. I'm going to go close folder. And then I'm going to go File, Open Folder, and let me navigate to the chapter section that I'm working on. I've got everything in many subfolders. I'm going to select that subfolder, and it's got everything that I need on here. Okay. So a class to test. So how is testing a class similar to testing a function? Testing a class is similar to testing a function. Much of your work involves testing the behavior of the methods in the class, but there are a few differences. So let's write a class to test. Consider a class that helps administer anonymous surveys. So let me open up the first one on here. So I've got one file called survey.py, and it has a class called, see, it's got a class called anonymous survey, and it collects anonymous answers from a survey question. It's got an init method, a show question method, a show store response, and a show results method. The driver will be, or the client will be language_survey. Here we go ahead and import survey, or from survey, import anonymous. So the name of the file is survey, and we're importing the anonymous class. So we'll go ahead on line 4 is create a string that we then pass during the instantiation of the object on line 5. Then on line 8, we show the question and store the response to the question using the dot operator. So we have the instance.showQuestion, and that's coming from, since we created an instance of anonymous survey, showQuestion is coming from this class right here, right? Then we print out enter Q at any time to quit, and then we have a loop. While true, we input the language, and if the response is equal to Q, then we break. Otherwise we go ahead and store the response and then say thank you. Okay, so let me go ahead and run that, and I'll go over all of this again. So when I run this, for language, I'm going to go ahead and put in English. Next language, I'll try Spanish. Next language, well, I guess I'll go back to English again. And next language, Mandarin. Mandarin, right? And then I'll quit. So when you quit, it says, thank you everyone who participated in the survey, and here are the survey results. Okay, so let's go ahead and discuss this. We haven't done any testing yet. This is just the class that we're going to end up testing. But we have to understand this before we end up doing a test for it. So how does this class work? The anonymous class. Let's take a quick look at this class first of all. I know I went over it briefly, but let's go over it again. This class starts with a survey question that that you provide and includes an empty list to store the responses. See, that's done in the init method, right? The class has methods to print the survey question. Here it is right here with self.question. Add a new response to the response list. That's done with the append method. And print all the responses stored in the list. That's done in this for loop where we have a print, where we print all the responses. So to create an instance from this class, all you have to do is provide a question. So let's come back over here to this driver class, and we create our instance right here on line 5. So to create an instance from this class, all you have to do is provide a question. And the question I'm providing is, what language did you first learn to speak? What language did you first learn to speak? I assign that string to question and pass question to anonymous. So that when I instantiate an object, I'm going to call my object my_survey. So over here during the init, it gets the question and it stores the question in the attribute called self.question. And then what we're going to be doing here is we also have a list that is initiated or created an empty list called responses. And then we're going to end up adding those to the list. Okay. So to create an instance from the list, all you have to do is provide a question. Once you have an instance representing a particular survey, you display the survey question with the show question method, store a response using the store_response method, and show results with the show results method. So here we have in the driver program here on line 8, I called instance.showQuestion. And then on line 14, I call instance.showResponse or store response, excuse me, it stores it. And that's using the append. So it's appending response to the list. And then finally, we call the instance.showResults, which shows everything to the screen. That's when we end up calling this method right here, show results. Okay. To show the anonymous survey class works, this is the driver question, the driver program that will do that. This question defines this program defines a question: what language did you first speak? Right up here on the top on line 4, and creates an anonymous survey object with that question. That happens on line 5. The program calls show question to display the questions and then prompts for responses. Each response is stored as it is received. When all the responses have been entered, the user inputs Q to quit. The show results prints the survey results. And that's where we end up getting this output that we saw here. Yeah, here it is right here. This is the output. See how the output's got the little dashes on there? See the method over here that we called the formatted string? We use this loop to create that. So a discussion of the above. This class works for a simple anonymous survey, but let's say we want to improve the anonymous survey and the module it's in, survey. We could allow each user to enter in more than one response. We could write a method to list only unique responses and to report how many times each response was given. We could write another class to manage anonymous surveys. Implementing such changes would risk affecting the current behavior of the class anonymous survey. For example, it's possible that while trying to allow each user to enter multiple responses, we could accidentally change how single responses are handled. To ensure we don't break existing behavior as we develop this module, we can write tests for the class. So now we come to how do we go ahead and write a test for this. So let me go ahead and close this, and let's take this up to the next level here. So we didn't do anything to survey remains the same, language survey remains the same. Now we're building test_survey as a file. All right, so let's go ahead and talk about this because survey is still the same. Survey has the class anonymous survey. It's got the init method, the show question, the store response, and the show results. The client, in this particular case, hasn't changed as well. And the test question, this is where, or yeah, it did change a little bit. We did, but we're not going to be messing with the client. We're going to go directly to the test. All right. So in this test at the top, we see we import unit test. Then on line 2, from survey, import anonymous survey. Okay, so these are the only two things that we need to be thinking about right now: the survey and the test. So on line 4, you'll notice that this class inherits from unittest.testCase. The doc string says that it tests for a class. For the class, these are tests for the class anonymous survey. In here, we have one method. And then we close with this if statement that tests for the special variable name to see if it's main, in which case we run the unittest.main. So inside this store single response, this is where, this is where I go ahead and instantiate my object inside the method. My instance is on line 11. And then I call store response, pass it. In this case, I'm passing it English. So it's kind of like you're taking the interaction out of this, right? So the question is, what language did you first learn? And instead of me typing in English, I just go ahead and say response.store response and pass it English. And then the next line here, I use the assert in to see if English is inside of the list called responses. Because remember, once we go ahead and create this instance over here, we're also creating a list called responses. So what I do is I add English to responses, and then I check to see if English is inside of responses. Okay, let me go ahead and run this and see what I get. And of course, it ran one test, and I got one dot because one test was made, right? And it was successful, I know, because it says okay. All right, so everything went fine, on this. So what did we just do? What did we just do? We wrote a test for the anonymous class. If we verify that one aspect of this is behaving correctly, so we wrote a test to verify that a single response to the survey question is stored properly. We'll use the assert in method to verify that the response is in the list of responses after it's been stored. Discussion. So to repeat, we start off by importing the unit test module and the class that we want to test, anonymous survey. That's done here on lines 1 and 2. Okay. We call our test case test anonymous survey, which again inherits from unit test case. That's done here on line 4. We must have this inheritance going on. Otherwise, if we don't have this inheritance going on, we won't be able to use these assert methods. So we get the ability to use these assert methods because we're inheriting from test case. Very important that we understand that. So the first test method we verify, or we'll verify that when we store a response to the survey question, the response ends up in the survey's list of responses. A good descriptive name for this response is test underscore store underscore single underscore response. I know that's really long. Slide 7. Look at this. Test underscore store underscore single. But the reason why that's good is because it's a good descriptive name. So if this test fails, we'll know from the method name shown in the output of the failing test that there was a problem storing a single response to the survey. To test the behavior of a class, we need to make an instance of the class. We create an instance called mySurvey right here on line 11. Here's the instance. That's the object. So to create the object, we've got the name of the class, we pass it question, and that creates the object called mySurvey. Okay. We create an instance called my underscore survey with the question, what language did you first learn to speak? We store a single response English using the store underscore response method. Then we verify that the response was stored correctly by asserting that English is in the list my underscore survey dot responses. When we run test underscore survey, the test passes. We know it passes because we got okay. This is good, but a survey is useful only if it generates more than one response. Let's verify that three responses can be stored correctly. To do this, we add another method to the test anonymous. So let's go ahead and close this and let's take this up a notch. So survey is unchanged. We're not going to be doing anything with the main program. But let's go ahead and open up test survey. Now what's changed here? Well, not line 1 and 2, not the class, and not the if. What we did is we added one more method, this method right here. See the test underscore store underscore single underscore response. I have to say that, right? That's what we already built that. So we added this one right here on line 15, this other method. So this, the doc string tells us very clearly what this method does. Tests that 3 individual responses are stored properly. So what does it do? The question is, what language did you learn to speak? That is passed to my instance on line 19. And then on 20, I go ahead, instead of doing this interactively, I just go ahead and put in English, Spanish, Mandarin. All right, and so I've loaded that up into responses. And then what I do here is I use a loop for response in responses. I'm going to go ahead and store the response in the instance. So it's my survey dot store response. If you go and look at that, the store response here uses the append method, and it appends new response to responses. That is an attribute. So we got 2 attributes in the instance. We've got the question and we've got this list called responses. Okay. So then we have another loop for response and responses. Then I go ahead and use the assert in method to see if this response is in my underscore survey dot responses, which is the attribute. Okay. And then lastly, we have the if statements to test to see if it's running from main, and yes, it is, right? So discussion, we call the new method a test underscore store underscore 3 underscore responses. We create a survey object just like we did in the test underscore store underscore single underscore response. We define a list containing 3 different responses, and then we call store underscore response for each of these responses. Once the responses have been stored, we write another loop to assert that each response is now in my underscore survey dot responses, the attribute, right? So when we run the test, again, both tests for a single response and for 3 responses pass. So let me go ahead and run this. And see how I got 2 dots now? Ran 2 tests and okay. This works perfectly. However, these tests are a bit repetitive. So we'll use another feature of unit tests to make them more efficient. So let's take this up another notch. And let me open up survey. That doesn't change. Our driver program, that doesn't change because we're just doing the tests right now. All right. So how are we taking this up a notch? We are introducing the setup method. There's also a teardown method, but your author doesn't cover it. So let's just talk about the setup method. Okay. What else has changed here? Nothing. Well, line 1 and 2 haven't changed, that's for sure. We've got this class called test anonymous. Yes, we did add a setup method here. And then what we did is we had to modify the other method so that they have the self prefix on here so that we can access this instance from anywhere in the class. That's basically what happened. But I'm going to go ahead and go over it line by line. Okay. So in test survey, we create a new instance of anonymous survey in each test method. In the previous one, okay? In the previous one, we created a new instance of anonymous survey in each test method, and we created new responses in each method. We're going to do it a different way now. We're only going to do this instance inside the setup method. If you want to go and verify that difference, you can. So the unit-test.testCase class has a setup method that allows you to create these objects once and then use them in each of your test methods. Before you include a setup method in a test case class, Python runs the setup method before, it's a very important word, before running each method, starting with test underscore. Any objects created in the setup method are then available to each test method that you write. So let's take a quick look at the setup method and what it's used for. We create a survey instance and a set of responses that can be used in test underscore store underscore single underscore response and test underscore store underscore 3 underscore responses. Okay. Look at this very carefully here. On line 12, this is where I create my instance. And then look very carefully on line 13. This kind of like simulates that prompting that we did before. We just create the list, and you notice how we've got this self prefix on here. And that's very, very, very important. I'll be drilling down on that. Okay, so the method setup does two things. It creates a survey instance and it creates a list of responses. Each of these is prefixed by self. See that? So they can be used anywhere in the class. This makes the two test methods simpler because neither one has to make a survey instance or a response. The method test underscore store underscore single underscore response verifies that the first response in self.responses, that is self.responses 0, can be stored correctly. And test underscore store underscore 3 underscore responses verifies that all 3 responses in self.responses can be stored correctly. When we run test underscore survey, again, both tests still pass. These tests would be particularly useful when trying to expand anonymous survey to handle multiple responses for each person. After modifying the code to accept multiple responses, you could run these tests and make sure you haven't affected the ability to store a single response or a series of individual responses. When you're testing your own classes, the setup method can make your test methods easier to write. You make one set of instances and attributes in setup, and then use these instances in all your test methods. This is much easier than making a new set of instances and attributes in each test method. So did I run this? Let me make sure. So we're gonna get ran. So it's the same thing as before. We got the 2 dots. The biggest difference on here is inside, we've got this setup method, and we're using the self prefix on here so that we can use these attributes throughout the class. So what is this dot? I think we've covered it before, but let's make sure that we understand what these dots mean in the output. When a test case is running, Python prints 1 character for each unit test as it's completed. A passing test prints a dot. A test results in an error prints an E, capital E. A test that results in a failed assertion prints a capital F. This is why you'll see different number of dots and characters on the first line of output when you run your test cases. If a test case takes a long time to run because it contains many unit tests, you can watch these results to get a sense of how many tests are passing. Okay. So excellent concept here. I guess I should show you the first contrasted again rather than just talking about it. Let's take a quick look at test survey from our first model on here. Notice how I created the instance inside of the method, right? And in the next level on here, we created 2 methods, but we kept having to create the instance inside of each method. You see that? So now what we're doing is we're only doing the instance 1 time inside of a setup method. So we don't have to do that inside of each method. So we took that part out, created the setup method, put it in here, and then we use the self prefix to access it throughout the class. Excellent, excellent, excellent demo. All right, so let me close all these so that we don't have a lot of things I'm on the screen, because we're going to go ahead and drill down on try this 11.3. Okay. So let me read the problem definition first. So the problem definition of 11.3 is called employee. It says write a class called employee. The init method should take a first name, a last name, an annual salary, and store each of these as attributes. Write a method called giveRaise that adds $5,000 to the annual salary by default, but also accepts a different raise amount. Write a test case for employee. Write 2 test methods. test underscore give underscore raise, and test underscore give underscore custom underscore raise. Again, these may seem really long, but they're descriptive. So they're kind of like self-documenting as to what they do. It's not as crazy as you may think at first. We're also going to use a setup method so that you don't have to create a new employee instance in each test method. Run the test case and make sure that both tests pass. Okay, so let's go ahead and let's make sure I'm in the right one. And I've got employee first. Let's just talk about employee. So it says write a class called employee. All right, the init method should take the first name, right? Last name, annual salary, and store each of these in attributes. So I did that. See how this is going on? This is the init method right here. See that? It initializes the object, right? So it receives first name or F name, L name, salary, and assigns those to self.first, self.last, and self.salary. Got that? Then it says write a method called giveRaise. I do that on line 10. And that adds 5,000 to the annual salary by default, but also accepts a different raise. So it uses this accumulator on here, and the book doesn't really cover that. I guess he assumes it's just too easy for you to understand. It's the long way of writing this line on line 12 would be to say self.salary gets, which is the equal sign, self.salary plus amount. So the first time you come in here, salary is 0 and amount is 5,000. So self.salary becomes 5,000. If you were to call it again, then it would increment it, but then it would be weird, right? But we're gonna assume that this is only going to be called once, right? I'm sure everybody would like to have this called many, many times on them on here. So what we're going to do then, it didn't tell us to build a client, but I did anyway, because I always like to like pretend how I can use this class. So let me go ahead and show you my client. It didn't, the problem didn't ask for it, but I went ahead and did it anyway. So I created 2 employees, one called Eric and one called Bob. And Eric, the author of your book, he's making 65,000 and I'm getting 100, right? Obviously, right? Even though we all know he's doing really good with his book, even though he doesn't charge very much for it. It's one of the most successful books on the market for the beginners right now. His Python Crash Course, great name, great website. I hope you feel the same as I do. It's worth rereading after you finish the class. Okay, so I'm going to go ahead and give Eric a default raise. So first of all, I want to just print out first name, last name, salary, and then call give raise. So if he's making 65,000, and if I call give raise, he's going to add 5 to that. It should show 70, right? I mean, you can do this in your head, but we're going to write a test for this in just a minute, right? And then in the next one here, Bob, I just do the same thing. And I'm going to give Bob a $10,000 raise. See, because when you just do raise, the default is 5, right? But if I pass 10, then it's overridden and the 10 goes in there. So if I'm making 100, then you can expect that my salary is going to end up being 110,000. Let me just go ahead and run it to see if I'm lying to you or not. So let me delete the stuff from the past, and just so you can have a clean little output on here. So Eric is making 65,000. He gets a $5,000 raise. His salary is now 70,000. Bob was making 100. We pass in a custom raise of 10K. Now he's making 110,000. It's working as I would expect. But let's go ahead and write some tests. Okay, so we're going to go ahead and test this, and I put that inside of a file called test underscore employee. And let's just take a quick look at this. Oh, it looks like I set a breakpoint. I'm going to come back to that in a little while. So needless to say, let's just talk about this whole thing. The parts of this is that we've got an import statement for, we need to import unit test, and then we need to import the employee class from the employee file. So from employee, import employee, right? Then lastly, we test to see what's inside the special variable called main to see if it's main, and if it is, we run unit test.main. This is main, so it runs the class. So this will not happen unless you have this if statement, okay? Because nothing happens, if you just have a class by itself. So if you'll notice, I have inheritance on line 5. I inherit, this class inherits from unit test.test case. That gives me the ability to use the assert methods. So inside of my setup, I guess I'm only gonna test one guy, right? Did I only consider? I guess I did. Inside of the setup, I'm going to go ahead and instantiate an object, and it's going to be called Eric, right? That's going to be the attribute right on here, right? So we pass Eric Matthews 65,000. Then I've got the test underscore give underscore default raise. And in this particular case, I call give raise. Okay, got it. And then I call assert equals, and I compare the attribute to 70,000, which it should. Okay. All right. And I guess I only needed to do one because I think I was going to go and do mine on here, but I didn't finish. So let me just go ahead and run this and just consider this a little bit of an unfinished idea on here. Well, let's see. I'm going to go ahead and run this. So we ran 2 tests and it works out. Okay, things work out. What I wanted to do is I wanted to go ahead and I know we talked about the idea that the setup gets done first before the other ones. So let me just go ahead and set up a breakpoint and walk into this so that we can see the logic on here, okay? So I'm going to set a breakpoint right here on line 10, and then I'm going to go ahead and go to run, start debugging, Python file, and I'm just going to go ahead and do a step into, okay? And let me go ahead and lower this down a little bit so that we can see what's going on. And we'll take a quick look on the, maybe we can see the informative things on the left-hand side here. So I put the breakpoint right there. So as you can see, self is main, which is kind of neat that you can go ahead at the special variables on here if you wanted to drill down on this sort of stuff. Let me just continue to go and step into this. So we see right away that the setup method was called before anything else. So now I go step into, and what happens now? Then it goes and instantiates the object, right? See how we're now in the employee class? See how the flow of control jumped to the employee class, and it passes first name, last name, and salary. Okay, and then notice how line 10 now is the line that's going to be executed, but hasn't been executed. It's the flow of control. Where's it going to go after this? Because we've already instantiated the object. It goes and does one of the tests here. It's going to go ahead and do the give raise. And if you'll see how it increments the amount. And it comes back, and then it does the assert. and then it comes back to the top up there, and let me do another step into. So we have the instantiation, right? And he goes and does the other one. Give raise, this is the default. It increments it, and it does the assert, and then comes back to unittest.main to gets out. So what do you get from this is basically, remember in the book, it says that it's going to go ahead and run the setup method before it does any of the tests. So these tests, remember that it's a very special word here. It's test underscore. Okay, these are the unit tests. So that when I run this, it ran two. Okay, it ran two because I had two unit tests that were run, and they came out all right. Okay. All right, my friends, that's the end of this chapter on unit testing. We discussed, testing functions and testing classes, and it used a lot of object-oriented thinking, and it's kind of like a good review of your object-oriented chapter. So in this chapter, you learn to write tests for functions and classes using tools in the unit test module. You learn to write a class that inherits from unittest.testCase, and you learn to write test methods that verify specific behaviors your functions and classes should exhibit. You learn to use the setup method to efficiently create instances and attributes from your classes that can be used in all of the test methods for a class. Testing is an important topic that many beginners don't learn. You don't have to write tests for all the simple projects you try as a beginner, but as soon as you start to work on projects that involve significant development effort, you should test the critical behaviors of your functions and classes. You'll be more confident that the new work on your projects won't break the parts that work, and this will give you the freedom to make improvements to your code. If you accidentally break existing functionality, you'll know right away, and you can still fix the problem easily. Responding to a failed test that you ran is much easier than responding to a bug report from an unhappy user. Now that's worth repeating. Let me repeat that. Responding to a failed test that you ran is much easier than responding to a bug report from an unhappy user. Other programmers respect your projects more if you include some initial tests. They'll feel more comfortable experimenting with your code and be more willing to work with you on projects. If you want to contribute to a project that other programmers are working on, you'll be expected to show that your code passes existing tests, and you'll usually be expected to write tests for new behaviors you introduce to the project. Play around with tests to become familiar with the process of testing your code. Write tests for the most critical behaviors of your functions and classes, but don't aim for full coverage in early projects unless you have a specific reason to do so. So that, my friends, is the end of this chapter on testing your code. We covered testing your functions as well as testing your classes. And thank you very much for your attention. Goodbye.